So today we're going to talk about starting off trig. So this is going to be some trig review that we're going to do right now. So trig review, welcome back. So casting our minds back to what we had historically. Trig is of course the math of triangles. And let's just revisit some stuff. So the first thing I want to just revisit really quickly is Pythagorean Theorem. So to make this work, ladies and gentlemen, what we're going to have to do is you're going to actually have to stop and engage and try some of these things, just like we would do in class where we actually run in class as normal. So when I present a problem, what I'd love for you to do is actually pause it and give it a whirl. So casting our mind back, what is Pythagorean Theorem? Well, again, it is, most of us remember it as a squared plus b squared equals c squared, but I would encourage you to remember it in the alternate form, which is c squared equals a squared plus b squared. And the reason for that is because we're going to continue on. We're going to learn a new formula, new to some of you, not new to all of you, called the cosine law. And cosine law starts with this version of Pythagorean theorem. So it's going to be a great idea for you to actually remember it like that. So I'm going to just toss up a basic one. So imagine that we had a triangle that had two sides of 5 and 12. And I guess just a really quick refresher on right angle triangles. Recall, of course, that for right triangles, what we have, I'm just going to make sure that we remember the appropriate lingo. When we have a right triangle, and we're going to have different sides. Wow, those drawings are a thing of beauty. This is going to be called, if you recall, it is the hypotenuse. And the hypotenuse is located, we can always find the hypotenuse because it is opposite the right angle. It's also, one of the other properties about it, aside from being opposite the right angle, so I'm going to put that as opposite the right angle, is of course that it's always going to be, that's one property, and the other property is it's always going to be the longest side on the triangle. Okay, so it's going to be the longest side. The other two sides are called, probably not many of us are going to remember that, but they are called legs. And so legs are the other two sides. And so when we think about Pythagorean theorem has some specifics for it in that the c is always the hypotenuse. Okay, so c is always going to be the hypotenuse. And then the other two sides can be the legs. And it doesn't matter which one is which, but those two sides can be the legs. So over here, this side would have to be side C, and this could be A and B or B and A. It doesn't really matter which is which. So if I want to solve for this, imagine I've said, not imagine, what I'd like you to do right now is I'd like you to solve for X. So go ahead, do that really quickly. And I'll give you a couple seconds. So you can pause, and then you can come back when you've got it done. So in this case, you don't always have to label them, but I'm going to label them. I recognize that this side over here is opposite the right angle, so this is going to have to be side C, and then this can be A and this can be B. So we're going to have that C squared is equal to A squared plus B squared, and we know in this case that C is going to be X, so I'm going to substitute that in. So we're going to have X squared equals 12 squared plus 5 squared. So we're going to have then that x squared is equal to 12 squared is 144, 5 squared is 25. So then we're going to have that x squared is equal to, of course, 169. And so that's x squared. We don't want just x squared, we want x. So we're going to root both sides, and we're going to find out then, of course, that x is actually equal to 13. So the unknown side length there is going to be 13. So I'm going to put up another one of these ones for you to give a whirl to.